Under this subtopic, we are going to understand rationalizing denominators. And we need to understand what is it that we mean by rationalizing denominators. If a fraction has a surd in the denominator, it is sometimes useful to rearrange it so that the denominator is a rational number. And this is called rationalizing the denominator. How do we go about rationalizing the denominator? If we have an expression that is 1 over root a, to rationalize the denominator, we need to multiply by root a on both sides, both the numerator and the denominator. And it must be understood, when we multiply by root a over root a, this is simply like multiplying by 1, because this is 1. By root a we'll get 1. That means eventually we will not change the value of the original expression. But look what we get from here. 1 times root a is root a, and root a times root a is a, and that is rationalized. But how is root a times root a? Let's go back to what we understood in the surds. If we want to talk about root a times root a, this is the same as a raised to power a half times a raised to power a half, which is the same as a raised to be a half plus a half, which is the same as a raised to power 1, and this is a. So that is how this ends up being a. We need to understand that if you have a over a plus root b, we need to multiply both the numerator and the denominator by the conjugate of the denominator. The conjugate of the denominator, as far as that is concerned, is the same denominator but with the opposite sign. So we have a minus root b over a minus root b. Again, if you cancel out, it's just like multiplying the original expression by 1. That means we change nothing. So if you have 1 over a minus root b, again, to rationalize the denominator, we must bring on the conjugate, which is a plus root b, the same denominator but with different sign this time round. Again, when you cancel out, this part gives you 1. So it's just like multiplying the original expression by 1, ending up not changing the original expression numerically in any way. So I want us to straight go to example 14, and example 14 talks of part A. Let's talk about part A. 1 over root 3. 1 over root 3. The conjugate of the denominator is itself root 3. So root 3. Root 3 times 1 is root 3, and root 3 times root 3, we have realized it is a 3, and that has been rationalized. Look at part B. Part B, we have 1 over 3 plus root 2. The conjugate of the denominator is 3 minus root 2 over 3 minus root 2. And it goes without saying, now 1 times 3 minus root 2, it remains 3 minus root 2 on top there. But this one, the way we open the denominator, we need to open the way we open brackets normally. So 3 times 3, 9. 3 times minus root 2, we are going to have minus 3 root 2. Root 2 times 3 plus 3 root 2. Root 2 times minus root 2 is minus 2. Let us simplify the denominator, and there is something interesting to be explained here. 3 minus root 2, that is as far as the numerator is concerned. Of course, minus 3 root 2 plus 3 root 2 will cancel out. And that is the fundamental reason Why we should bring on the conjugate with a different sign? Because we know the third part will cancel out. The third part will cancel out. If we brought positive here, then would have made this third part just in more than what we had. But the fact that we have brought the negative sign, we want to ensure, or our basic reason to bring the negative sign here in the conjugate is to ensure that the third part will eventually cancel out and remain with the whole number part. So 9 minus 2 is simply 7. And that is how we get that answer. If you go to part C talks of root 5 plus root 2 all over root 5 minus root 2. Root 5 plus root 2 all over root 5 minus root 2. What is the conjugate of the denominator? The conjugate of the denominator is root 5 plus root 2. Root 5 plus root 2. Note the change of the sign. And our duty now is simply to open up this bracket using FOIL or any other appropriate method. Root 5 times root 5 is simply 5. Root 5 times root 2 is root 10. And root 2 times root 5 is another root 10. And root 2 times root 2 is going to give us a 2 all over. Now that we realize that the conjugate has different signs, there is no point of multiplying out each and every term. We only need to multiply out the first and the last. We need to omit the outer and the inner, because eventually we know they will be cancelling out. But for the sake of those who want to see, root 5 times root 5 is 5, and root 5 times root 2 is plus root 10, and minus root 2 times root 5 is minus root 10. Already you can see, and root 2 times root 2 is minus 2. So let's find out what is at the numerator. 5 plus 2 is 7. Root 10 plus root 10 is 2 root 10 all over 5 root 10 minus root 10 is 0. And then the denominator only has 5 minus 2, which is a 3. And that is the final submission as far as part C is concerned. 7 plus 2 root 10 all over whole number 3. Let us see what happens in part D. Let us just see what happens in part D. Part D, let me rub what we have up there. Part D. In part D we have 1 over 1 minus, this is 1, root 3 squared. This one needs to be taken care of a little bit, because before we go to the conjugate, we must find out what is actually at the denominator position. And we will only do that after we expand the denominator, meaning that this is going to be 1 over 1 minus root 3, 1 minus root 3, which is 1 over 1 times 1 is 1, 1 times minus root 3, minus root 3 times 1 minus root 3, and then we're going to have minus root 3 times minus root 3 is going to be simply a 3. Once we collect the like terms here, we are going to simply have 1 plus 3, which is a 4, 1 over 1 plus 3 is a 4, minus a root 3 minus a root 3. If you consider root 3 to be a boy, so minus a boy minus another boy, so minus 2 boys. So that is our expression. So this question is now reduced to this part. So we rewrite it afresh and have 1 over 4 minus 2 root 3. At that point now, we can simply rationalize the denominator by multiplying by the conjugate of the denominator, which is 4 plus 2 root 3 over 4 plus 2 root 3. I keep saying, the moment you multiply by the conjugate at the numerator as well as at the denominator, it's just like multiplying the original expression by 1, and therefore we are not afraid that our expression will be numerically changed, so it will not. So 1 times the whole of that will be, the numerator we have 4 plus 2 root 3. The denominator now, we can now avoid the 2 inner multiplication and simply talks about the first and the last. So 4 times 4 is 16, minus root 3, minus 2 root 3 times 2 root 3 is minus 4, because minus 2 times 2 is minus 4, and root 3 times root 3 is 3. So 4 times 3, which is simply 12. So the final answer is going to be 4 plus 2 root 3 all over, rather 16 minus 12. And what do we have? We're going to have 4 plus 2 root 3 all over 4. But if you look at it critically, you will find that the denominator can easily cancel out the numerator. So we can have 4 over 4 plus 2 root 3 over 4. And this eventually is going to give us 1 plus root 3 over 2, or a half root 3 eventually. But if you may not be interested in giving us this one, you can easily give a general LCM, which is a 2. 2 divided by 1 is 1. 2 divided by 1 is 2, times 1 is 2, plus 2 divided by 2 is 1. So 2 root 3 over 2. So any answer is acceptable. All right?